Now that we know a little bit about rational exponents, we're going to look at how to simplify with them. We have two goals here. First, simplifying in exponent form. We'll do 3 examples there, and then we'll do 3 examples simplifying in radical form. Okay? So let's look at exponential form. When you're simplifying in exponential form, pay attention to how your directions are stated. Simplify each expression, write your answer in exponential form. It will tell you what your final answer should look like. So we should still have exponents instead of radicals at the end of our problem. Okay? Rational exponents are just exponents. So you are going to use the same exponent rules that you would for whole numbers. And I've put a reminder here. Multiplying like bases means add exponents. Dividing like bases, subtract your exponents. Power to a power, multiply your exponents. And negative exponents, you reciprocate. Okay? All right, so let's look at example 1 here. We have a multiplication and we have a power to a power. So I like to first look at simplifying inside the parentheses if you can. We have a 16, an x, and a y. There are no like bases, so we can't simplify anything there. So let's go to our power to a power rule. So we have this 1/2 power, and it needs to be multiplied to all of the exponents inside. I want to remind you that the 16 has an exponent as well. That is an exponent of 1. A lot of times the 16 or the number, the coefficient, gets left out because we don't always see the exponent there. But it always has an understood exponent of 1, which means the 1/2 needs to multiply to 1. 1/2 multiplies to 1/2. 1/2 multiplies to 2. I'm going to do that work by hand, but you can use a calculator. So first, the 1/2 goes to the 1. So 1 times 1/2 would give me 1/2. So that's going to give me 16 to the 1/2. Okay, now the 1/2 needs to multiply to the 1/2. So 1/2 times 1/2, and what would you get? That would be a 1/4. 1 times 1, 2 times 2. So that would be x to the 1/4. Okay, now the 1/2 needs to multiply to the 2. So 1/2 times 2. Multiply numerators, multiply denominators. That's like a 2 over 1. And that would be 2 and 2. Always simplify if you can. So 2 over 2 would become 1. So that is a y to the 1. So I just went through and did my multiplication. Now I look to see if there's anything else I can simplify. When I have a number to a power, I want to try to evaluate that. Okay? 16 to the 1/2. What is the power of 1/2 equivalent to? It's the same as a square root. So instead of saying 16 to the 1/2, I could say the square root of 16. And we know what the square root of 16 is. We know that it's 4. So that gives us 4. A 1/4 exponent can't simplify. A 1 exponent can't simplify. We don't want to change the 1/4 to rational or to a radical because it tells us to leave it in exponential form. So we're going to leave it in exponent. And our final answer is 4 x to the 1/4 y. You can write y to the 1, but you do not have to write the 1. Okay? Let's try it again. So if we look at the second one, we have a division here. Okay? So we got to think about our rules for division. I want to caution you, 6 and 3 are not exponents. So do not apply your exponent rules to them. 6 and 3 are just coefficients. You're just going to treat them like regular numbers. 6 divided by 3 is 2. Okay? Now we're looking at our exponents. X to the 3/4 divided by x to the 1/4. We have like bases, x and x. So what do we do with our exponents? We need to subtract them. So let me do that subtraction. So we need to do 3/4 minus 1/4. Always do top minus bottom, okay? Even if it turns out negative, it's okay. So 3/4 minus 1/4, we subtract our numerators because our denominators are the same. So 3 minus 1 is 2/4. And 2/4 can simplify to 1/2. So that just becomes an x to the 1/2. I check for any more simplification. 2 is already simplified. 1/2 can't simplify. We leave it as an exponent. There's our final answer. All right, and let's look at this last one here. We have a multiplication. It looks like a lot, but just take it one piece at a time. So I have a number and a number, an x and an x, a y and a y. So I'm going to do each piece paired up together. Again, make sure you treat your numbers like numbers and not exponents, okay? Like coefficients. So 12 times 2 is just 24. All right? Now let's look at our x's. X to the negative 2 and x to the 1/4. We are multiplying the bases, so what do we do with the exponents? We need to add them. So that's going to be an exponent of negative 2, and I need to add it to an exponent of 1/4. Okay, you can use your calculator here, but I'm going to remind you how to do it by hand. If I want to add, I'm going to think of that as a negative 2 over 1, and I need common denominators. So common denominator would be 4. I'm going to multiply by 4 over here. So times the top by 4, times the bottom by 4, and I'll get negative 8 over 4 plus 1/4, and that gives me negative 7 over 4. So that means that x to the negative 7 over 4. Okay? Make sure your exponents look like exponents. With these fractional exponents, it's easy to make them too big, so just be very careful with your formatting. All right, and then lastly, we need to look at our y's. Y to the 2/5 times y to the 3/2, 3 over 2. So I'm going to do the same rule. I need to add my exponents. So I'm going to do 2/5 plus 3 over 2. I need common denominators, so I'm going to choose 10 because I can get them both to match. So that'd be 4 over 10 plus 15 over 10, which is 19 over 10. Okay, 19 over 10 can't simplify, so that is going to be my final exponent. All right, now if I look at my answer, I only have one problem. I have a negative exponent still in my problem. Never leave negative exponents. You're not fully simplified until you take care of negative exponents. All it means is it's on the wrong side of the fraction bar. So if it's on top of the fraction and it has a negative exponent, then it needs to move to the bottom. If it's on the bottom and it has a negative, it needs to move to the top. So let's write our final answer. 24 does not have a negative exponent, so it stays in its spot. X to the negative 4 over 7, that's a negative exponent, so I move it to the bottom. Okay? And then y to the 19 over 10 is a positive exponent, so it stays on top. Sorry, 19 over 10. So there's our final answer. So all we did was move our negative exponent to the denominator. And we are done. Okay, so now that we've simplified an exponential form, let's look at radical form. I've broken it up into 3 main steps for you to keep track of your work. Again, notice our directions. Write your answer in radical form, which means we should have some type of square root, cube root in the end. Okay? First, I like to separate my coefficient and simplify that, get it out of the way. Then I'm going to convert my variables to exponential form. When we are in exponential form, it's a little bit easier to simplify. So we'll convert to exponential form, then convert back to radical form in the end. And then lastly, you want to write your exponents as a mixed number in order to convert it to radical form. So let's see what that looks like. So in example 1, I've got the square root of 144, x to the 7th, y to the 10th. So I'm going to break it apart. I got the square root of 144. I've got the square root of x to the 7th, and I've got the square root of y to the 10th. Okay? So I'm going to start with the square root of 144. What is the square root of 144? It's 12. That part's done. That's as simplified as it could be. All right, the square root of x to the 7th, I want to convert to exponential form so that we can simplify it. Remember, this has an understood index of 2. So how would you write the square root of x to the 7th in exponential form? The index is your denominator. So when I write that exponent, it's going to be x to the 7 over 2. Okay, the square root of y to the 10th would then be y to the 10 over 2. Now I want to go through and write my fractions as mixed numbers. So 12 is complete. I'm just going to bring that down. X can be written as, so 2 goes into 7 3 times, which would give you 6, with 1 left over. So that's 3 1/2. Okay, 2 goes into 10 5 times evenly. 10 divided by 2 is 5. So we have 3.5 and we have 5. This one is fully simplified. This one still has a fraction. Remember, if you have a fraction as an exponent, then you have a radical. Okay, so we need to convert this piece. So we need to actually separate it from the whole number so that we only have the part that needs to be underneath the radical. So I'm going to write that as x to the third times x to the 1/2. Think about your exponent rules. If I multiply, I can add my exponents, right? 3 plus 1/2 is the same as 3.5. So this is an equivalent expression. And what this allows us to do is separate the part not in the radical from the part that needs to be in the radical. And then I have y to the 5th that needs to come down. All right, to write our final answer, all the pieces that have whole number exponents come first. All the pieces that have fraction exponents come second. Okay, so we have the 12, the x to the third, the y to the 5th. All three of those do not have a fraction as an exponent, so they are not in a radical. I'm going to put them first. Okay, x to the 1/2 has a fraction as an exponent. I need to change it to a radical. So if I have x to the 1/2, what is that the same as? That is the square root of x. So I write that at the end, and then I'm done. All right, let's just see it 2 more times going through. So here we have a cube root of 64a, b to the 5th. Again, separate your number and your variables. Okay, I'm going to simplify my number. The cube root of 64 is 4. Okay, the cube root of a we need to change to an exponent. So what would it be as an exponent? A to the 1/3. And then I need to change the cube root of b to the 5th as an exponent. So that would be b to the 5/3, since our index is a 3. Okay, I need to check, can any of these change to a mixed number? The 1/3 can't, but the 5/3 can. Okay, that would change to 1. 3 can go into 5 one time with 2 left over. So that's 1 2/3. Okay, I'm going to separate the whole number from the fraction. So that's going to be b to the 1 and b to the 2/3. So I just separated so I can see exactly what goes underneath the radical. Okay, so I have 4, doesn't have a fraction as an exponent. B to the 1 doesn't have a fraction as an exponent. I'm going to write those first. And then if you notice here, their index is the same. Index of 3, index of 3. So these can actually go underneath the same radical, and that will be a cube root. Okay? And there's 1a and 2 b's. So a, b to the 2. And that's your final answer. All right, last one. Cube root of 8, r to the 17th, s to the 4. Oops, separate. Sorry about that. Come on. There we go. Cube root of 8. Cube root of r to the 17. Cube root of s to the 4. Okay? Cube root of 8. What is the cube root of 8? Good. Okay. The cube root of r to the 17, I'm going to rewrite, is r to the 17/3. The cube root of s to the 4, s to the 4/3. What is 17/3 as a mixed number? That would be 3 goes into 17. How many times? Let's see. 4 times would be 12. 5 times would be 15. So 3 goes into 7. Oh, goodness. Why does that keep happening? 5 times with 2 left over. So 5 2/3. And then s. So 4/3 could be rewritten as a mixed number as 1 1/3. Okay? Now, if you feel comfortable, you could skip this step of separating and go straight to what comes first, what comes second. I'm going to go ahead and write it one more time for those of you who'd like to see it again. So 2, r to the 5th, r to the 2/3, s to the 1, s to the 1/3. Find the pieces that don't have a fractional exponent. Those come first. Okay? And then the pieces with the fraction need to go into the radical. So what is the final answer here? It would be 2 r to the 5th, s. You could put s to the 1. And then our index is a 3 because that's our denominator. There are 2 r's and 1 s. And there we are.